we will be constructing the margin of error for a proportion. So the gap between the best point estimate and the population proportion is called the margin of error, and it is calculated using critical values. So this is the formula. E equals, this is the z critical value, times the square root of p hat times q hat divided by n, where again z is a critical value, p hat is a sample proportion, q hat is 1 minus p hat. So p hat is the sample proportion of successes, and q hat is the proportion of failures. So that's going to be 1 minus p hat. So we're going to have to do some calculations there. Now to calculate the width of the confidence interval, we're going to have to double the margin of error, which is 2 times the margin of error. Let's look at the critical values. To get a critical value, the standard z-score, remember the z-scores from our previous chapter here, are likely to occur and those that are unlikely to occur. Such a z-score is called a critical value. So they're based on the following observations. The sampling distribution of the sample proportions is approximated by the normal distribution. Remember, with the normal distribution, we use the z-scores. So a z-score associated with a sample proportion has a probability of falling in the right tail, which is denoted z sub c. So we're going to be using this chart. You'll be able to use it during your test, and you don't have to memorize these. These are the most common confidence intervals. I will only ask those confidence levels. Okay, so these are the critical values. How they're calculated out, I'll demonstrate by the 95%. Remember in the previous chapter, if you had 95%, you could calculate out these values here, okay, by going probability of z is less than or equal to, remember it's between, and the 0.95 is on the right hand side of the equal sign. And when you did that, you got the negative 1.96. and you would get positive 1.96. So those were the values in there. So we're going to say that if it's a 95% confidence level, we're going to only use the positive z critical value of positive 1.96. So that's how to get the critical values. Pretty much just look on the chart. Now the margin of error. To calculate the margin of error, it says in a survey of 1,550 adults, 1,054 said they used the website Instagram. Use this information to find the margin of error for the population proportion of U.S. adults who use Instagram with the confidence levels of 80%, 95%, and 99%. Describe what happens if the margin of error as the confidence level increases. So we're going to look to see what happens as the confidence level increases. We're going to show the general formula, specific, and numerical value. So the formula first is, we'll copy it from above on the previous page. Remember, it's going to be E equals the z critical value times p hat times q hat all over n. So let's look and find our values here. At the 80% mark, our z critical value we're going to use is going to be 1.28. Our p hat for the problem is going to be 1054 over 1550. Let's see if that converts to a nice decimal instead. Okay, and remember from a previous problem we had calculated that out, and that was 0.68. So 68% is a sample percentage. Q hat, then, if we calculate Q hat, it's going to be 1 minus 0.68. If you need to use your calculator, you can. And that is 0.32. So 32% do not use Instagram. So p hat, q hat, we have to then know what n is as well. N in our problem is going to be the same, which is 1,550. So let's substitute all these values into this problem. 1.28 times the square root of p hat, which is 0.68, times q hat, which is 0.32, divided by n, which is 1,550. Let's do this on our calculator. So 1.28 times the square root. Let's scoot it over here for you. It's a bit better light. Then 0.68 times 0.32 divided by 1550. You can exit out of there. Remember, make sure 0.68 times 0.32 divided by 1550 is all under the square root, then hit enter. And I'm going to write this out, 0.0151660,878, which is approximately, if I convert it to a percent, that would be approximately 1.5%. Okay, so the margin of error if at 80% confidence level is 1.5%. Let's try the next one, 95% confidence level. Again, we're using the same formula. Except now we're going to have a different critical value. Now we have 95%. So our Z critical value when it's 95% confidence level is going to be the 1.96. The only thing that's different in the problem is we are going to substitute 1.96 in for the Z critical value times, and the P hat and Q hat stay the same. So it's going to be times the square root of 0.68 times 0.32 divided by 1,550. Okay, so again, practice that on the calculator. 1.96 times the square root of 0.68 times 0.32 divided by 1,550, and I'm going to write all those down, and if I round it to do it as a percent, that would be approximately 2.3%. So far our margin of error is going up, isn't it? Our last one, our 99% confidence level, okay, we can use the same general formula, Z critical value times the square root of P hat times Q hat all over N, and our Z critical value is going to change now. Our Z critical value at this level of 99% is 2.575. These critical values are often rounded to 2 or 3 decimal places. So we're going to take 2.575 times the square root of P hat 0.68 times Q hat 0.32 divided by our sample size 1,550. Go on the calculator and put that in. So our critical value 2.575 times the square root 0.68 times 0.32 divided by 1,550, hit enter, 0.030. And so that's going to be approximately 3.1% if we just round it to, I'm rounding it to 3 decimal places there for each of those. Whoops, it should be there. Okay, so now to answer the other question in our problem. Our question says here, describe what happens to the margin of error as the confidence level increases. So at an 80% confidence level, our margin of error is very small. At a 99% confidence level, our margin of error is very big. I always think of confidence levels as a bullseye. If you were to throw, right, a dart at a bullseye, if you have a larger confidence level, okay, the higher chance you're going to hit it. If you have a lower confidence level, okay, I'm sorry, lower confidence level, that means it's going to be bigger. And if you have a higher confidence level, it's going to be bigger, and if you have lower confidence level, it's going to be smaller. Okay, so if you have a lower confidence level, if you're going to throw the dart and you have a low confidence level, that means the bullseye is pretty small, so that's why you have a lower margin of error. If you have a large bullseye, your confidence level is going to be fairly large, and the bullseye is going to be much larger.